Two definitions, range and interquartile range. Range is the difference of the greatest value and the least value, which is also the difference between the maximum value and the minimum value. Interquartile range is the difference between the third quartile and the first quartile. The third quartile, again, is halfway between quartile 2, or the median, and the maximum, and the first quartile is halfway between the minimum value and quartile 2. To find the range in the interquartile range, we can use a set of data. We want to first make sure the data is in order from least to greatest. And for the range, again, we want to find the difference between the maximum value and minimum value, or the greatest value and the least value. The maximum value will be 28, and the difference will subtract off the minimum or lowest value, which is 18. 28 minus 18 would be 10, so our range for this data set would be 10. For the interquartile range, we need to first find the quartiles. If you remember, quartiles involve the median. We want to first find the middle number, or quartile 2. Looking at this data set, if we have 8 numbers, the median would be halfway between the first 4 numbers and the last 4 numbers. In this case, between 24 and 25 would be 24.5 or 24.5, and that would be quartile 2. For the interquartile range, we need to find quartile 1 and quartile 3. Quartile 1, again, would be halfway between the minimum value and quartile 2. Or if we have 4 numbers, halfway between the second and third number. Since these are both 22, that means quartile 1 is also 22. Quartile 3, again, would be halfway between quartile 2 and the maximum value. And in this case would be halfway between 25 and 27, which would be 26. Once you find the first quartile and the third quartile, we can then find the interquartile range. The interquartile range, again, is the difference between the third quartile and the first quartile, or in this case, 26 minus 22. 26 minus 22 would be 4, so the interquartile range would be 4. Choosing appropriate measures. When you have a set of data or different types of graph, we can decide what type of data the mean or median represents the data the best, and also we can decide if the standard deviation or the 5-number summary, which is the minimum, maximum, and 3 quartiles, represents the data best. For example, when the data of the distribution is symmetric, or if you have a graph that looks symmetric with some values on the left, some values on the right, and most of your data in the middle, you can use the mean to best describe the center of that data, and you can also use the standard deviation to describe the variation, or how much the data is spread apart. When the data is skewed, such as skewed left or skewed right, or if you have a graph with most of your data on the right-hand side and a little bit on the left-hand side, or a graph where most of it's on the left-hand side and some of it on the right-hand side, a skewed graph, the median, would be the best measure of center, and the 5-number summary, minimum, maximum, and the 3 quartiles would be best for the variation. Definition of an outlier. A outlier is a data value that is much greater than or much less than other values. If you have a set of data and the minimum value is farther away than all the other points, or if you have a maximum value that's farther away from all the other points, that point is considered an outlier. Looking at the first data set, if we have the numbers 1, 2, 3, 5, 8, and 20, looking for an outlier would be a number that's farther away from all the other numbers. In this case, that number would be 20. 1, 2, 3, 5, and 8 are grouped closely together, and the number 20 is a lot greater than all the other numbers. So in this case, the outlier of this data set would be 20. Last example for the section, given a new data set, the numbers 45, 55, 40, 47, 52, 20, and 51. You could organize the data from least to greatest and see if there's an outlier or a point that stands out as a minimum or maximum farther away from the other points. Or just looking at the data set, we have lots of numbers in the 40s and 50s, and we have a single number 20 that is less than 40 and 50 compared to the other numbers. So in this case, the outlier, or a number that is a lot less than the other numbers, would be 20. Relative frequencies. Another way to use a two-way table instead of the total amount of entries is you can use relative frequencies or joint relative frequencies or marginal relative frequencies inside the two-way table. A joint relative frequency is a ratio or percent of a frequency that is not in the total row or the total column to the total number of values of observations. A joint relative frequency are basically numbers inside the two-way table that represent the number of yeses or nos or number of people in certain groups, but it's represented as a percent or a decimal. A marginal relative frequency is the sum of the joint relative frequencies in a row or a column. Marginal relative frequencies are basically the numbers outside the two-way table that are in the total row or total column. When finding relative frequencies in a two-way table, you can use either corresponding decimals or percents, and you can round the numbers as necessary. Another type of relative frequency is the conditional relative frequency. A conditional relative frequency is the ratio of a joint relative frequency to the marginal relative frequency. The joint relative frequencies, again, are numbers inside the two-way tables, and the marginal relative frequencies are the numbers outside the two-way tables or the numbers in the total columns or rows. You can find a conditional relative frequency using a row total or a column total of a two-way table. When you find conditional relative frequencies and instead of using the total amount given, you'll only use the total for a single row or use the total for a single column. Two-way tables with relative frequencies. Given a two-way table such as this, with rows of juniors and seniors, and answers to the question, do they buy lunch at school? Either yes or no. We can take these numbers that represent the specific number of juniors and seniors and change them into relative frequencies. Before we compute the relative frequencies, we first need the total of each row and each column. If we add boxes to the bottom of the two-way table, and we add boxes for entry points on the side of the two-way table, and we can also have a corner box to represent the total for the entire two-way table. For example, the number of people that said yes to buying lunch would be 124 juniors and 101 seniors. If you add those together, that would be a total of 225 people that said yes, they buy lunch at school. If we answer the question for no for buying lunch, again, 219 juniors, 236 seniors. If we add those together, that would be a total of 455 people that said they do not buy lunch at school. Going across the rows, juniors, 124 said yes, they buy lunch. 219 said no, they do not buy lunch at school. If you add those values together, which would be 343, that would represent there's a total of 343 juniors. If we do the same for the seniors, 101 said yes, they buy lunch at school. 236 seniors said no, they do not buy lunch at school. Adding across would represent 337 seniors in the survey. For the total column at the bottom right, we can either add the juniors and seniors together, or we can also add the number of yeses and nos for buying lunch. That total should be the same in either direction. In this case, that number is 680, which represents 680 people included in the survey. Once we have the total of the rows and the columns, we can then draw a new table to represent the relative frequencies. In this new table, instead of the number of juniors and seniors and number of yeses and nos, we'll represent the relative frequencies using either decimal points or percents for the amount of juniors and seniors and the amount of yeses and nos. For example, the percent or decimal point for juniors that said yes, they buy lunch, there is 124 juniors that said yes out of 680 total. If we divide 124 divided by 680, 124 juniors divided by 680 people in the survey. As a decimal point, rounded to 2 decimals, that number would be 0.18. This would also be 18%, which means 18% of juniors said yes, they buy lunch at school. We can do the same for each of the other columns. For example, juniors that said no would be 219, divided again by the total, 680. 219 juniors said they do not buy lunch at school, divided by the total number surveyed, 680. As a decimal point again, rounded to 2 decimal places, this would be 0.32 or 32%. Continuing on, 101 seniors and 236 seniors that said yes and no. If we divide each of these by 680, the decimal points or percents for seniors would be 0.15 for yes, seniors buying lunch at school, and 0.35 for no, seniors not buying lunch at school. These again are the joint relative frequencies. The joint relative frequencies are inside the two-way table, whereas the marginal relative frequencies will be outside the two-way table. To find the marginal relative frequencies, we could take these numbers from above, divide each one by 680. Another way to solve that is to actually add the joint frequencies together in each row or each column. For example, 0.18 plus 0.15 would be 0.33, which would be the same as 225 divided by 680. If we add the no's for buying lunch at school, 0.32 plus 0.35, that would be 0.67. Finishing off the two-way table, adding the rows going across, 0.18 and 0.32 would be 0.5 or 0.50. Same thing for the senior row, 0.15 and 0.35 would be 0.5. For the bottom right corner box, we can either add the column going across or the row going across. Again, that value should be the same, and in this case, that value is 1. The 1 represents 100%, and these other marginal relative frequencies, 0.5 would represent 50%, and 0.33 would be 33% or 67%. In terms of the table, that means yeses were 33%, nos were 67%, and in the survey for juniors were represented by 50%, and then the seniors were 50% of the survey also. Two-way tables with conditional frequencies. Conditional frequencies, again, instead of being based on the entire table, are only based on a single row or a single column. In this two-way table, we have either freshmen or sophomores that answered either yes or no as to whether they own a pet. Before we do conditional frequencies again, we can find the marginal totals for the outside. Again, we can add boxes for the total for yeses and nos, and we can add boxes for the total of freshman and sophomore. And that'll also give us a bottom right corner, which would be the total number of people in this survey. For the number of yeses for owning a pet, 64 freshmen said yes, 54 sophomores said no, 54 sophomores said yes. If we add those together, 64 and 54, that would give us a total of 118 people that said yes, they own a pet. For the no's, 30 freshmen said no, 40 sophomores said no. If we add those together, that's 70 people that said no to owning a pet. Going across the table for the rows, 64 freshmen said yes, 30 freshmen said no. If we add those together, that gives us a total of 94 freshmen in the survey. And again, 54 sophomores said yes, 40 sophomores said no. If we add those together, that'll give us a total of 94 sophomores in the survey. For the bottom right corner, which is the total number of people in the survey, we can either add together the total number of freshmen and sophomore, or add together the total number of yeses and nos. Both those should be the same, and that value is 188. Once we have the totals, or the marginal frequencies, we can then find the conditional frequencies. In this question, we want to find the conditional frequencies based on the column total. Conditional frequencies, again, can either be based on the columns or the rows, and for this question, we'll be using the column totals. What that means is for the percents or decimals, instead of dividing by the total number of people in the survey, which is 188, we'll divide by the column totals, which is 118 for the yeses and 70s for the nos. For example, 64 freshmen said yes, they own a pet. We'll take that 64 and divide by the column total, which is 118, or 64 divided by 118. If we write that as a decimal point, that would be 0.54, which is also 54% of the people that said yes are freshmen. We can also divide for the sophomores, 54, and again for conditional frequencies on the column, we'll divide by 118. 54 divided by 118 will give us a decimal of 0.46, or 46% of the yeses came from sophomores. If we do the same for the no's, 30 freshmen said no, 40 sophomores said no, and again we'll divide by the column total, which is 70. So for the freshmen that said no, 30 divided by 70, and again rounding to 2 decimal places, would be 0.43. And likewise for sophomores, 40 divided by 70, rounding to 2 decimal places, would be 0.57. And again, these numbers represent the conditional frequencies based on the column totals. 54% of the yeses came from freshmen, 46% came from sophomores. For the no's, 43% of the no's came from freshmen, and 57% of the no's came from sophomores. There's 2 types of data. Qualitative data or categorical data consist of labels or non-numerical entries that can be separated into different categories. When using qualitative data, operations such as adding or finding the mean do not make sense. Qualitative data is some type of vocabulary or a word where we cannot add or take an average of that vocab word. Quantitative data consists of numbers that represent counts or measurements, where we can do our typical mean or add or find the quartiles for quantitative data. Qualitative or quantitative. When given a description, we can decide if the data collected would be qualitative or quantitative. The first description would be names of students in your second period class. If you think of a list of names, which would be vocabulary words, would not consist of any numbers, this data would be qualitative data. Qualitative data, again, is some type of vocab word or list of vocabulary words. The second type we could use, instead of names, if we have test scores of students in your second period class, test scores would be some type of percent or number score. If you have any type of number or numerical value, that data would be quantitative data. Quantitative, again, is any type of number or numerical value. The third set that we can look at would be heights of students in your second period class. If you think of somebody's height, that could be represented in feet or inches, which would both be quantitative or numerical values. Quantitative, again, is some type of number or numerical value that we could take averages of, make graphs of, or find the quartiles for. And the last set that we'll look at, hair color of students in your second period class. Hair color would be some type of vocab, such as red, brown, or blonde. Vocabulary, again, would be qualitative data. Qualitative data we cannot find a mean for, we cannot find an average or quartiles for, but we can gather that data and it would be qualitative.